Welcome to this explainer. I'm so glad you're here. Today, we're going to create a nice, calm space to explore the quiet physics that power our digital lives. It's so easy to just take the technology humming away in the background for granted, but there's this elegant, almost peaceful science making sure you stay connected. So picture this, it's midnight. You are typing the final brilliant paragraph of a massive term paper, and suddenly the lights in your room flicker and completely die. Outside, pitch black. The whole street is out. But right there in front of you, your screen is still softly glowing. What exactly is happening in that moment? What keeps your screen glowing when the rest of the world just goes dark? Well, today we're exploring the deeply reassuring science of your battery backup. Okay, let's dive into this. Section 1. The flowing invisible energy, the quiet power behind your screen. So, to really understand how your backup catches you when you fall, we've first got to look at what's actually flowing through your power cords every single day, this continuous, invisible energy. Electric current, it's defined simply as the rate of flow of electric charge, measured in amperes. Now, if you aren't an engineering major, please don't let the terminology intimidate you. Frame current not as some scary, unpredictable spark of electricity, but rather as a peaceful, natural river. It's just this steady stream of electrons flowing smoothly to keep your laptop running. But, a river needs a little push to keep flowing, right? And that brings us to potential difference, which we commonly know as voltage. Think of voltage as the work done when a unit positive charge is moved from one point to another. Or, to ground that abstraction in everyday reality, just think of voltage as unseen pressure. It's literally the necessary energy input that guarantees your desk lamp stays lit while you study. Now, before that invisible river even reaches your wall outlet, the energy goes through quite a journey. It's this beautiful three-step process. First, naturally occurring, chemically bonded energy, like coal or nuclear energy, is converted into heat. Next, that heat operates a thermodynamic cycle to create mechanical rotational movement. And finally, that mechanical energy runs a generator to produce electrical energy. So the power you casually use, it's actually a carefully transformed natural force. Section 2. Storing the spark safely. Hoarding energy for a rainy day. Because we have to ask, what happens when that long journey of generation is just suddenly interrupted? Let's look at how we capture this energy to effectively build a reliable safety net for your coursework. We generally hoard this energy in a couple of different ways. We've got batteries, which directly obtain electric energy by converting chemical energy, and then we have capacitors, which store energy temporarily in the form of an electric field between plates. And while they work a bit differently, both methods do the exact same absolutely crucial job for you. They just sit quietly in the background, hoarding energy until the exact moment you need it. Now, what's really interesting here is the difference between passive and active network elements. A battery backup acts a lot like a shapeshifter. While your house has power, it's just a passive element, happily receiving and storing energy. But the absolute second the power blinks, it seamlessly shifts into an active source, instantly supplying the energy your electronics desperately need. Which brings us to Section 3, your temporary power net, creating a safety buffer. Let's look at how much safety we actually have stored up, because there is a deeply reassuring math to this. Okay, look, I know you might see differential equations on screen and immediately feel a slight sense of academic panic. Please, don't be intimidated by the math here. You don't need to solve these today. This math simply proves a very comforting concept. We can reliably capture and hold a precise amount of energy between two parallel plates. That right there is the literal blueprint of your safety buffer. And this brilliantly illustrates how, if we just take that power and integrate it over time, we arrive at this beautifully simple formula. It's the math that physically secures your unsaved documents. W equals 1/2 CV squared. I really don't want you to view this as just a rigid academic hurdle or, something to memorize for a pop quiz. The W represents the energy stored, C is the capacitance, and V is the voltage. Let the simplicity of this formula act as a comforting anchor. It is the mathematical proof that you have a safety net waiting to catch you. Section 4, the gentle winding down. Time to hit save. So the lights go out, your backup shapeshifts into an active source, and it starts using that stored energy. What is that experience actually like? Check out how this builds visually. These waveforms show how current, charge, voltage, and energy all act in a capacitor. Notice how smooth and predictable the curves are. The energy rises predictably when storing. Honestly, a lot like filling up a calming, warm cup of tea to the very top. And when it's time to drink that tea, when the power is cut and the battery is draining, it doesn't just vanish instantly. So the crucial point here is this concept of a decaying exponential response. Now, I know the word decay sounds like a terrifying rapid countdown, but it's really not. In a circuit, this is just a gentle, highly predictable winding down clock. The math shows that at exactly one time constant, a value drops to 36.8% of its initial value. Let me reassure you, reaching 36% isn't a failure of your device. It's just physics doing exactly what it is supposed to do. It's providing a mathematical grace period, giving you precisely enough time to calmly hit save on your work before the screen fades to black. Section 5. Peace with your power. Finding calm in the circuit. Let's summarize how all of these unseen forces perfectly align to give you some peace of mind. I really love this concluding thought from the text. Circuits are composed of 6 basic types of ideal elements. These laws obey the principle of superposition and homogeneity and are hence linear. Now, if that sounds a bit dense, let's just translate it into plain English. It means electrical laws are fundamentally linear and predictable. And because of that, the technology protecting your digital life is completely reliable. It isn't random, it follows the rules. The math of a circuit is beautifully predictable, which means you never have to panic when the lights blink. You're protected by the basic laws of electrical engineering. Next time your screen stays perfectly lit in a dark room, will you take a moment to appreciate the quiet math saving your work? Thanks for exploring this explainer with me. Take a breath, hit save, and have a great day.